Great, solving 5x minus 9 equals 26. To solve this for x, we are going to first of all add 9 to both sides. So I'm going to get 5x equals 35, and then to get rid of the 5, we're going to divide both sides by 5, and I will get x equals 7. Right, the next one, we still are going to solve for x, but I want to get rid of some things first. I'm going to get rid of the parentheses by distributing. So I'll get 9x minus 18 plus 5 is equal to 7x plus 3. And then I'm going to combine like terms over on the left side. So I'm going to get 9x minus 13 equals 7x plus 3. I now know that I need to get the x's on the same side. So to get rid of a 7x, I'm going to do minus 7x to both sides. So I'm going to get 2x minus 13 equals 3. And then to continue solving for x, I will add 13 to both sides. So I'll get 2x equals 16. And then to get rid of the 2, we'll divide both sides by 2. I will get x equals 8. Okay, problem 24, absolute value of x equals 5. I know with absolute values, I should expect most of the time to get 2 answers. So if I do this, I'm going to get x equals 5 and x equals negative 5. Simple as that. Because the absolute value of negative 5 is 5, and the absolute value of negative 5 is 5. All right, this next one, we are going to go ahead and solve. The first thing I want to do is to get rid of the minus 3, so I'm going to add 3 to both sides. So now I have 2 absolute value x plus 1 equals 8. The next thing that I want to do is to get rid of the 2, so I'll divide both sides by 2. So I'm going to get the absolute value of x plus 1 is equal to 4. And then from here, since I have the absolute value isolated, I can set up 2 equations. X plus 1 equals 4, or x plus 1 equals negative 4. And then from here, I just solve it. I'll subtract 1. I'll get x equals 3. I can subtract 1, and I'll get x equals negative 5. So once again, I have 2 answers. Okay, problem 26. We've got some absolute value graphing going on here. When we do an absolute value, remember we're going to get x minus 3 is greater than or equal to 9. And then we've also got x minus 3 is less than or equal to negative 9. Notice I changed the sign, and I changed the sign on my number. From here, we're just going to solve both of these. On this one, I'll add 3 to both sides, so I'll get x is greater than or equal to 12. And then on this one, if I add 3, I'll get x is less than or equal to negative 6. So go to my graph. Negative 6 goes on the left, 12 goes on the right. They both get a closed circle because there's an equal sign. If I'm bigger than 12, that's pointing towards the right, and if I'm less than negative 6, that would be pointing to the left. So notice I have my actual solving, and I also have the graphing. Okay, 27 asks me also to solve and graph. Again, I'm going to have 2 separate inequalities. X is less than 3, and then I'm also going to have x is greater than negative 3. And no solving to do, I'm just ready to graph. So negative 3 will go on the left side, 3 will go on the right. They will both get open circles because there's no equal sign in the inequality. And then less than 3 is going to the left, greater than negative 3 is going to the right. So this is going to be a situation where they connect in the middle. And just one comment on this one, if it's connecting another way that I could write that would be negative 3 is less than x, which is less than 3. So just in case you see a multiple choice that looks like that, that's how you would tackle it. Problem 28, solve 7x squared plus 4x minus 3 equals 0. All right, this is a quadratic, so I know that I get to use one of my methods. Please remember the methods are factoring, square roots, quadratic formula, and graphing. And we're going to use a variety of these. I'm going to choose to do the factoring on this one because I think it will be able to factor quite nicely. I'm going to have 7x and 7x, and then I'll end up dividing by 7 when I'm done. 7 times negative 3 is negative 21. And then my choices, let's see, I'm going to have negative 7 times 3, negative 3 times 7. I notice that a negative 3 plus 7 will give me a positive 4, so that's exactly what I'm looking for. And then I need to divide the 7 out of one of the parts. I'll divide it out of that second one. So this will be 7x minus 3, and then this will reduce to x plus 1. Don't forget 7 divided by 7 is 1. Okay, from here we do want to figure out where this would equal 0, and I basically just, for this one, I can just take the opposite. It's going to be x equals negative 1. On this one, I take the opposite, but I also have to divide it by the 7. So it's going to be 3/7. So that would be my answer on that one. You could definitely also, if you did not notice that this was a good factoring one, you could have used the quadratic formula and it would have worked quite nicely. Graphing would not work so well. Okay, number 29, 3x squared plus 17 equals 65. Again, it's a quadratic, so I know I have several methods. Since we are missing the x term, I'm actually going to use the square root method on this one. So I'm going to subtract 17 from both sides. So I'm going to get 3x squared is equal to 32, I believe. Let's see. No, that works. 65 minus 17. No, how about 38? We'll do better on that one, I believe. 19, 38. Nope. How about 48 on that one? Get it right sometime. 3x squared equals 48. Okay, now from here, we're going to divide both sides by 3. So we'll get x squared is equal to 16. And then to get rid of the square, we'll take the square root of both sides. So we'll get x equals 4. But remember, we actually get 2 answers, so we'll get plus minus 4. This one also would have been a good candidate for the quadratic formula as well. Okay, number 30, we've got 3x squared minus 2x minus 15 is equal to 0. I know that if I tried to factor this one, it's not going to factor nicely. If I graph it, it's not going to graph nicely. And sometimes you can tell that if you go ahead and graph it and then notice it doesn't touch at very nice spots. Quadratic formula is actually the best one to use. So I am going to do the quadratic formula. My a is going to be 3. My b is going to be negative 2, and my c is going to be negative 15. So here we go. We've got x equals opposite b, so we'll get 2 plus or minus square root b squared, which is 4, minus 4ac all over 2a. All right, so I've got everything set up, and then from here, we can let our calculator do the work for us. If I follow the plus for the first time, I should get x equals 2.59 rounded to 2 places, and then if I follow the minus, I should get negative 1.93. All right, number 31. Although we can use many methods on this one, it is a quadratic, so I've got lots available. I'm actually going to, I'll do 2 different ways on this one. The first way that I'm going to do is factoring. It is set equal to 0, so I'm set to go with that. And I notice that I can take the square root of each part, so this will actually just be x plus 5 times x minus 5. And then if I take the opposites, I'll just get x equals to negative 5 and positive 5. Right? So that was one way. I'm also going to use it with the method of square roots, just in case you chose that one instead. Okay, if I'm going to use the method of square roots, I need to get the x squared by itself, so I'm going to add 25 to both sides. So I'm going to get x squared equals 25. And then from here, to get rid of the square, we'll take the square root, and I get x equals 5. But remember, we get positive and negative 5. So notice both of those gave me the same answer. All right, number 32, x squared minus 5x equals 24. It is quadratic, so I have lots of methods available. I believe I'm going to choose factoring on this one. If I'm going to factor, it does need to say equals 0, so I'm going to subtract 24 from both sides. So I'm going to have x squared minus 5x minus 24 is equal to 0. And then since it's a quadratic trinomial, I can factor it as x and x. 1 times negative 24 is negative 24. Let's see, negative 6 times 4, negative 4 times 6, negative 8 times 3, negative 3 times 8. I'm looking for a negative 5, so a negative 8 and a positive 3 will give me negative 5. So here we go, negative 8, positive 3. And then if I'm solving by factoring, I just have to write the opposite. So it's going to be 8 and negative 3 for that one. Okay, the next one, since it says, what are the x-intercepts of the function y equals x squared minus 8x minus 20? Since it's actually asking me for x-intercepts, I think it will probably be easiest to graph this one. So I'm going to go ahead and graph this one. And if I graph it, let's see here. I think it's going to hit way over here at 10. And it's also going to hit at negative 2. So I believe when you graph it, you're going to get something, whoops, it should go right through there, that touches like that. And it said, what are the x-intercepts? My x-intercepts are x equals 10 and x equals negative 2. So that would be my answer on that one. Okay, couple story problems here. Number 34. An arc of water sprayed from a lawn sprinkler can be modeled by the graph of the equation y equals negative 0.05x squared plus 0.9x, where x is the distance in feet from the sprinkler and y is the height in feet of an arc. How far from the sprinkler does the water hit the ground? Okay, if I'm hitting the ground, my y or my height is going to be 0. So I've got an equation. It's a quadratic equation. I have lots of choices available. I believe on this one I'm going to do the quadratic formula just because there are decimals, so it looks a little messy for factoring. So I'm going to have A equals negative 0.05, B is equal to 0.9, and C is going to equal 0 because there's no part without an x. So here we go. X equals opposite B, so negative 0.9 plus or minus square root B squared, which would be 0.81, minus 4AC all over 2 A. There we go. Okay, and then from here, if we follow the plus, we just type it in our calculator. If we follow the plus, we actually end up getting 0. And then if we follow the minus, we end up getting 18. And if I'm talking about real life, how far from the sprinkler does the water hit the ground? 0 would just not make sense. So 18 is my answer, but let's get a unit on it. I was looking for an x value, and it says x is measured in feet. So this will be 18 feet. All right, number 35. A landscaper is building a rectangular brick patio. The area of the patio is A equals 5x squared plus 20x, where x is the width of the border around the patio. The landscaper has enough money in his pocket to budget to purchase patio bricks to cover 105 square feet. With this budget, what will be the width of the border? So he's saying 105 square feet, that's an area. So I'm going to put the 105 in for the A. So I've got 105 equals 5x squared plus 20x. All right, since this is quadratic, I know I need to choose one of my methods of solving. I believe I'm going to use the quadratic formula again, but if I'm going to use the quadratic formula, I have to get rid of that 105. So I'm going to subtract it. So I'm going to get 0 equals 5x squared plus 20x minus 105. Okay, my A will be 5, my B will be 20, and my C will be negative 105. So here we go again. X equals opposite B plus or minus square root B squared minus 4AC all over 2A. All right, from here again, we just get to type stuff in our calculator, and if you type the plus in, you will end up getting 3, and if you plug the minus in, you should end up getting negative 7. Obviously, negative 7 does not make sense in the context of this problem. So we'll have 3, and since we were measuring in 3 square feet, the width of that border needs to be 3 feet.